Server virtualization is a key area of technology investment that is creating large improvements in server efficiency and flexibility. Although server virtualization deployments depend on high-performance shared storage, most storage being used today is much less efficient and flexible than it could be. There is a large opportunity to improve storage efficiency and flexibility in virtual data centers by introducing new technologies such as clustered file systems. This presentation provides an overview of how products like Sanbolic's clustered file system allow customers to realize this opportunity today. Just how commonly used file systems contribute to inflexible data center architecture is typically not well understood. So let's take a minute and look at the role of the file system in the volume manager. Volume managers typically aggregate individual disk drives into larger pools of storage and present a logical drive to the operating system. A file system will install on that volume and keep track of which bytes make up a file and manage how data is written to and read from a storage device. The file systems in common use today were designed for direct attached storage with the assumption that only one server could access any given storage volume at a time. Each server has its own storage hardware. There's a separate file system for each server, and this creates a storage server silo. That is, data is owned by a single server, and access to that data is dependent on the availability of that server. In the last 10 or 15 years, shared SAN storage hardware has become common. These storage networks can enable multiple servers to access a single storage volume, but the file systems typically being used do not support shared access. Each server would overwrite the other server's data if given shared access in this environment. So SANs are typically configured so that each server has a separate storage volume and its own separate file system. Although the servers share storage hardware, they do not share data. There remains a storage server silo where the data is owned by a single server. Many data centers today consist of a series of silos. A storage volume is uniquely assigned to a server, an operating system is installed on that physical server, and then a single application is deployed on top. These silos are time-consuming to deploy or to change, and therefore typically are not reconfigured for short-term changes in workload. New application deployments typically require new hardware to be purchased and installed, and this leads to both low utilization and inflexibility to respond to workload changes or new opportunities. Virtualization is beginning to decouple the storage server application silos. Products like VMware ESX, Microsoft Hyper-V, or Citrix Xen Server allow multiple servers with their own operating system to easily be placed on a physical server and allow the virtual servers to be easily moved between physical servers. Products like Microsoft App-V and Citrix XenApp decouple the link between the application and the server, allowing an application to run without being installed. Server and application virtualization allows servers to be flexible resource pools that can be quickly reassigned when workload changes. This enables server consolidation, increased utilization, and improved availability and business continuity. Users can rapidly redeploy hardware to meet changes in workload, and users can rapidly deploy new applications to capture opportunities. But the storage layer remains tightly coupled, inflexible, and complex to manage, since most file systems in use today require a one-to-one mapping of a storage volume to a server. This results in lower storage utilization and creates a barrier to truly flexible data center architectures. Let's look at the implication of storage silos in the virtual data center. First, in a physical data center, if we have 10 servers to manage, there will typically be 10 or more SAN application volumes to manage. In a virtual data center, the 10 physical servers can be consolidated to one server. However, there are still 10 SAN application data volumes to manage. With Hyper-V, there may be 10 virtual machine volumes to manage. Application data volumes may need to be manually moved after a VM migration, and storage volumes for VMs may need to be administered locally. A clustered file system eliminates much of the complexity of the storage silos. A clustered file system enables multiple servers to share a single volume and file system with concurrent read and write access to files over a SAN fabric. Shared access to SAN storage resources greatly improves potential storage efficiency and flexibility. A clustered file system serves as a virtualization layer, decoupling the linkage between a storage volume and a single server. This allows data to be available even if a single server fails. Multiple servers can work on one copy of data. There's no need to replicate data for each server. Fewer storage partitions to provision, manage, and backup means lower operating costs and better storage utilization, and storage becomes a flexible resource pool, as virtual servers have already become. So why aren't clustered file systems used more often? Microsoft doesn't have one. VMFS is a core component of VI3 and vSphere in VMware's product suite, but has limited functionality and can only be used with ESX hypervisors, not for other workloads. Most third-party clustered file systems have been complex and optimized for a single type of workload, and metadata controller-based file systems create a single point of failure and scalability limitations. Melio Clustered File System and La Scala Clustered Volume Manager are new products from Sanbolic that overcome many of the limitations that have prevented wide deployment of this type of technology. They use a symmetrical architecture which is designed for high availability. There's no dependency on a metadata controller. They're highly scalable, file systems of up to 18 exabytes, and host clusters of many dozens to many hundreds of servers can be deployed, depending on workload. Ease of use is a key design point. They use a next installer, can be used with any SAN storage hardware, and use a native operating system interface for most management tasks. They provide better than local file system performance on large files and near local file system performance on small files, and they integrate easily with most Microsoft Server technologies. Melio and La Scala can be deployed on any physical or virtual server, whether that server is acting as an application server, a file server, or a host for virtual servers. When deployed on a server, that server has shared access to block storage, which is formatted with Melio's format. At the volume manager level, some of the functionality provided includes storage and performance aggregation across multiple storage controllers, central configuration and assignment of logical volumes, as well as software RAID. At the file system layer, some of the functionality includes providing a single file system and namespace for all servers, quality of service management on a per node basis, extended attributes and shared metadata, distributed snapshots, reporting on performance, as well as multiple paths to access files, essentially file multipathing.